If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE-sponsored podcast.
Hey, Friday.
Happy Friday.
It's Friday. It's October. The sun is shining.
In some places. Yeah, I was going to say it snowed here yesterday.
So I'm Mercedes Landazuri.
And I'm Lynzie Nebel.
And with our powers combined, we are
PlastChicks.
The voices of resin.
Look at us, all our resin.
Yeah. So we have a podcast sponsored by Society of Plastics Engineers, SPE Inspiring Plastics Professionals. We both work in the industry, and I specifically work in color. Lynzie?
I work in biopharma, injection molding, all that good stuff.
Brag, brag, brag.
Yeah, that's a brag.
Yeah. And we decided to start this podcast a couple of years ago. We met in the industry association, and we felt like we stood out because we were a little bit younger and a little bit more female than a lot of the people in the room. And we wanted to amplify those voices and just the voices of people doing exciting things in our industry. So this podcast is not just meant for people within the plastics industry, but people outside of it. To learn more. We welcome guests on every month. The podcast is released by SPE the first Friday of every month, and you can get it anywhere you listen to your podcasts.
And you can follow us on social media. We're on Instagram. We're on LinkedIn. And we say, and we'll probably say till the end of time, that we're going to be on TikTok, but we'll do it once it's super, super uncool. That's when we'll get on.
Yeah, I hear GIFs are now, or GIFs are now uncool. So I'm glad that wave is there. I'm glad that wave, because I could never figure out how you're actually supposed to say them.
Yeah, well, you just don't say it, you just do it. So.
Yeah. I think I've already sent you one today, Lynzie.
You have.
At least.
At least.
So uncool. So uncool. So with us today, we have our guest, Dr. Katrina Knauer. She's program manager at the National Renewable Energy Laboratory, and CTO of the Bottle Consortium. And she has multiple patents. How many patents are you on?
I'm not that super cool yet. I only have about 4 patents
only
in
four.
Space.
Fine.
So.
I think you're beating Mercedes and I collectively by 4.
By 4, yeah. So thank you so much for joining us today, Doctor. We really appreciate it. I think I met you virtually. I think I met you virtually in the 2021 RACE Recycling and Circular Economy Conference that SPE worked on, because I'm a member of the recycling division, and was really impressed with you, and was hoping that we could have you on the podcast someday. And several months later, here we are.
Yeah, I was excited to get the invitation. Happy to be here. Also, I can clear up one thing for you guys, that apparently the man who invented the GIF passed away last year, and on his deathbed said the correct pronunciation is GIF, and he wants people to keep saying it that way. And I thought that was just a fascinating way to go. So
R.I.P. GIF.
Yeah.
That's why they're going out of favor.
Right. If he was still alive, he could
he's Gen Z.
Keep the cool going.
Yep. So just a little bit of background history for you guys there. So now I'm just like, all right, I'm going to respect his honor, and I will call it GIF. And here we are.
Have to continue the legacy now.
Yes, exactly.
I love it. Did some internet stalking of you, Doctor, and saw that you did your undergrad in Florida. Is that where you're from originally?
Yep, I grew up just outside of Jacksonville, Florida, and I went to school at Florida State, and I am a Floridian.
Well, Jacksonville is actually a big music town, but this podcast isn't about music.
It is. I love that you know that. I feel like I loved growing up there because I actually was exposed to great bands. A lot of famous bands went to my high school, like Yellow Card and Red Jumpsuit Apparatus, and it was just a really fun town. I loved it. But I live in the West Coast now. I've been out west for a long time, and now I'm in Colorado, which I also love. So
And getting
like it's
snow.
good. And getting snow already.
Oh,
Gosh.
that makes sense. I was like, how did anybody beat Chicago for snow? But yeah,
Yep.
I guess
That's what I said about Buffalo Erie.
Yeah, that's exactly. It's shocking to people. It shocked me. I was like, wasn't it like 70 degrees last week? And yeah, so
Yes.
here we are.
So you started working in high performance materials at Florida State, which I know through my internet stalking, you really started to fall in love with polymers. So is that really what inspired to get you involved in this field? How did you really enter in this field?
Sure, yeah. I think at the time when I was at Florida State as an undergrad, you're just kind of still figuring out life and you don't really know exactly what you want to do or who you are. But I was always really passionate about environmentalism and environmental activism. And my younger self was probably more obnoxious than my older self. I was a big protester. I would like throw tomatoes at Burger Kings when they wouldn't pay equal wages to workers. And this, that was me at the time. But I was also very passionate about science. And when they opened up the High Performance Materials Institute at Florida State, they were hiring undergrads and they were paying quite well to work in the labs. And that's kind of what I saw at the time, was just some dollar signs and a job to put on my resume. And so I started working with the HPMI. And that's when I realized that plastics were polymers. And this really cool chemistry that I was learning how to do was also the chemistry contributing to this enormous waste crisis that we were finding ourselves in. But I was convinced that plastics were actually really awesome at the same time and so important to our quality of life. And that's what got me really passionate about, okay, how do we change this world to be more sustainable? How do we keep plastics in our lives, but have it be less impactful to the environment? So that kind of started that path of me being involved in recycling and circular technologies, was that intersection between environmental passion and then also really liking polymer chemistry and trying to combine the two to make a difference.
Right. I love that. And I love how you touched on that, which it's a quote I think I saw in a YouTube video of this Indian guru once. I don't think he's currently, or when he recorded the video, that he was working in industry, but he said something so astute that was, plastics are this environmental solution and we've turned them into an environmental problem.
Yep. I mean, it's perfectly said. Mm-hmm. Life would be worse without plastics. I mean, that is something we do have to keep in mind. Mm-hmm. They've done so much for our quality of life, but we unfortunately kind of went crazy with it, abused it in a way. And now we're trying to figure out what to do with all these carbons that are ending up in our natural environment. But I think it's always important to keep in mind that a broad, ban and elimination wouldn't really solve our problems.
Hashtag bills, not bans.
Yes. Yes.
And also hashtag Buffalo Bills.
Woo! Go Bills.
So after Florida, you went over to Southern Miss, which is, I know for Penn State grads, that's a big school to go to if you want to do the polymer side of things. And so anyone that's come out of there, I've already had like the highest respect of their knowledge because they are just the smartest of the smart people go there.
And Lynzie is a Penn State grad. She looks down on like almost every other
school. On so many people. So that is not true. But on top of that, like some of the smartest people I know, like I said, went to Southern Miss, like Dr. Allison Rhodes. I think she's damn genius. And, she's Southern Miss graduate. And, but you were inducted into the Graduate Hall of Fame at Southern Miss. How do you even get that level of smart?
And can we have your
autograph?
So I didn't even know that was something that existed when I got the
That's what smart people say.
But I was like, oh, what is this? I think the reason that happened is because at the time I realized in grad school that it was really, really cool and fun to win awards. And so I remember the first award I got, I was like, what? They give you money and recognition for science? And so that kind of started this addiction, honestly, where I was like, I'm going to win every single award out there. And so I just started going for every opportunity that was available to polymer scientists and chemists. I wrote paper competitions, I wrote into poster competitions, I just went for all of them. And so all of a sudden, Southern Miss was like, who is this chick winning all these awards? And
I think
so
that's a really healthy addiction, actually.
I know,
Yeah,
of all the addictions, it's the right one.
It was definitely the best addiction to have. And then also at the time, Southern participated in the 3-minute thesis competition for the first time, which is, if you guys aren't familiar, it is super fun. And it's a competition that encourages PhD students to present on their thesis in 3 minutes or less in a very tangible, multi-audience adapting way. And so they hosted this competition and I won that. And then I got to go to the national competition and then I won 3rd place there. And they were just like, okay, we're going to put her in the National Hall of Fame of Graduate Students, which was I was so honored and it was wonderful, but they also had this enormous portrait of me in the college. And I was like so embarrassed by it because it was also a picture of me, like they made me
Was it from the freshman Facebook?
No, thank God. They took a picture of me in the lab, but they made me lean against the counter with my arms up on it in my lab coat.
It's never a cool pose.
No, it looks so silly.
The bigger the award, the worse the picture.
Yeah, that's kind of how it
just
felt.
Be grateful you weren't doing one of these with the
okay, it was almost like that. At least they let me put both arms down. But they also keep it up only for so many years, and then they took it down and they gave it to me, and I was like, what am I supposed to do with this? So my partner thought it was really funny. He wrapped it up and gave it to my mom for Christmas.
I love it.
And my mom opened it and was like, am I supposed to hang this up? It was so funny. But that's how the Hall of Fame thing happened. And it was awesome. And I was very honored, even if I was just a little bit embarrassed.
Very cool. So then after that, when you entered industry, you started working for BASF. Mm-hmm. And, as a color person, I saw that you started working with a Mach 5 spectrophotometer. So
I did.
For those of you not there, it sounds really, really cool. For those of you who don't work in color, don't work with spectrophotometer is a tool used to measure color values. So can you, do you remember working with the Mach 5?
Yeah.
I'm just a super nerd when it comes to spectros. I have my little purse spectro
over
here.
Cool. The handheld one, right?
Yeah. Well, this little guy, it's from a company called Variable, but it's like this. So I literally carry it with me everywhere.
She literally uses it on flights.
Yeah, I use it on flights.
That's so cool. I love that. I could tell you what I was using the spectrophotometer for, which, by the way, I still use all the time, and I can tell you why there. At the time at BASF, and for those of you listening who are young and career researchers, it's important to keep in mind that you might not always go right into positions and technologies that you're super passionate about and want to be in. It is hard work. Like, you have to create a name for yourself and never shut up about what you want to do. And maybe you'll get there, because the reason I bring that up is I started in enzymes at BASF, which was really fun for me because I had no background at all in enzymes. And that's what I really enjoyed about that company, is they did offer these programs that let you go into a completely new field. So I started in enzymes, which there is an intersection there with plastics, in that we are developing enzymes for plastic degradation. But I was working on enzymes for detergent applications. So the reason I was using the Mach 5 is because we were actually trying to create these polymer enzyme coacervates that would make the enzyme more effective at removing very targeted stains from textiles. So we would have these swaths that were like green grass. It was grass stained swaths. So they would like blend grass and stain these cotton swaths with it. And then I had wine stain, I had blood stained. We would take all these and we would treat them with the enzyme polymer systems. And then I would use the Mach 5 to actually calculate and quantify the extent of color and stain removal from these textiles. So that's
so cool.
Wow. See, another use for your little handheld one.
Yeah, definitely. And the handheld ones now, so much of what our group does at NREL is a big problem in recycling, as you guys know, is color. That's a huge challenge.
Yeah.
And so as we are trying to create more virgin quality recyclates, a big part of that I'm teaching my postdocs now is you have to be able to quantify color. And so we just bought a brand new spectrophotometer that my boss was like, why is this $20,000? And I was like, because it's the best one and it's going to be really great. And but I think it'd be really cool to have handheld ones too, to do kind of quicker checks on color change of the recyclates and that kind of thing.
Yeah, you can do it just right on the line too.
Yep.
Yeah. So you had mentioned that, it was important for people. It's not easy to go immediately into your specific area of focus, your optimal area of focus, and that you need to be very vocal about it and where you want to go. And it sounds like that's kind of what you did at BASF, moving from enzymes to recyclability.
Yes, definitely. I again, going back to that concept of never shutting up about what you want. You may feel like you're being obnoxious, but it's how you continually tell people and get in their mindset of, oh yeah, Kat, she's really into sustainability and circularity, and she's a polymer person. She wants to work on recycling. These were the buzzwords I would constantly put in people's heads. And when I decided, so I was in a rotational program with BASF where I rotated. It's kind of like an industrial postdoc. And at the end of it, I decided to stay on permanently. And that's when I interviewed to go into the plastics division. And then within that division, specifically, I made it very clear in my interviews. I was like, I want to work on recycling technologies. I want to build this into a BASF portfolio. And even then, once I got the job, was a slow start. I mean, at the time, this was like maybe how many years ago? 4 years ago. And we were starting to talk about circularity more, but it wasn't as much momentum as we have today. And so even then, I kind of felt like it was pushing this rock up a hill. Like I was like, we really should be working more in this space. And ultimately, I got to start doing much, much more in ocean plastics and recycling. But it definitely wasn't just like, boom, I'm here. Let's work on exactly what I'm passionate about. It takes work and patience.
It's funny you say that, because even now, I've worked in the injection molding industry for so long, and now I'm at my new company and I'm in hardware, and it is, not plastic at all. So every chance I get, I was like, I know plastic.
I'm plastics.
Just so you
I'm
know,
a polymer
plastic.
Yes.
And I said the other day, I was like, I'm probably being obnoxious about it, but I'm okay with that.
Yes. Yeah, you should be, because that's just a reality of how careers kind of work. And I feel like in industry specifically, we are not as good at it as academics are, because the academics have to be that way. Like they have to get out their Twitter pages and they have to show the world, this is their research, this is what they're going to work on, so that people start associating their names with it. But in industry, we're not as good at branding ourselves. And so I actually think professional branding is so important. And I try to encourage many young researchers going to industry that professionally branding yourself is going to play such a big role in your happiness and your career. And we have to get better at doing it.
And you've done quite a bit of mentoring, I know, as well, right? Can you talk a little bit about that?
Yeah, sure. I love mentoring, and I definitely, when I was making the decision between going versus academia, that was probably the hardest part, because I do enjoy mentoring and teaching and educating and working with students. I was just so disenchanted with the academic world at that time and ready to make an impact in a different way that I went to industry. However, that being said, I was lucky enough at BASF that I did get to mentor interns and several young career technicians coming through, which I really, really enjoyed. And then that's also kind of what taught me how to start managing research projects and managing groups. And then when I went to the startup world, I also got to work with some really great young technicians that I loved working with and teaching them about polymers, because they didn't come from polymer backgrounds, and getting them excited about like, hey, maybe you can go back to school and do a PhD and get for higher education. And then now that I'm at National Lab, I get to hire postdocs into my team. And that's been really wonderful, because they're at such a great intersection in their careers where they just came out of school. They're kind of still deciding whether they're going to do industry or academics. And I love teaching them about circularity and sustainability while also helping them figure out their career path, and also teaching them how to professionally brand themselves and speak up for themselves. So I love mentoring. It's been a nice balance, especially at National Lab, that I get to do that without having to teach lots of classes. And so that's been great.
Yeah, I think that's such an underserved part of this industry. We have a lot of the like institutionalized mentorships. You're at this company, this person's worked there. Great, you guys can talk and they can be your mentor and you can move on. But I think a lot of the times if you don't have that in your company, which a lot of companies in the plastics industry do not, especially because they're smaller companies, mom and pop, custom injection, custom extrusion, all that stuff. I think we miss out on that opportunity. And the other opportunity is like to teach about outside of, if you're in injection molding, like to teach sustainability. Like that should be something we're teaching them from the outside in, inside out, but something so that they're thinking about it when they're actually, designing their mold or, designing these runners that are however long. And I think especially formalized mentorship programs really do go a long way on that kind of stuff.
They definitely do. And you guys being injection molders, you are in a unique place in the supply chain that there's a lot to teach younger people coming in or new people coming in, not always younger, that when we look at the demand for recycled content and demand for circularity, it's coming from the brand owners primarily because they're so consumer facing. But then the polymer producers are like, that's not really our problem. And so really it's the in-between, it's the compounders and converters and the injection molders and the OEMs that are like getting crazy demands from their customers to produce all this recycled content of equal quality and price. And they're like, we don't know what to do. Like, how do we get this supply? And that was a big part of a startup company when we were making these new polymers from chemically recycled monomers. I was trying really hard to work with injection molders because they could look great on an Instron, they could look great on a DSC, but do they injection mold? We don't know. And we can run rheology, we can run MFI, and that's all well and good, and we can check these boxes, but that is a different world once you start putting it on processing lines. And so when we start moving more towards these circular materials and recycled content and new plastics for the future, the injection molding world is going to be so critical to that step. So you're right, like teaching that is going to be really important.
Yeah. And I know, just from my past job, there have been times where it's been, okay, here's this, post-consumer recycled material, just sub that in, or it's not as critical, like, because I did a lot of dog toys, so it wasn't as close on, we didn't have a whole lot holding us, there weren't as many dimensions. It was basically, does it look good and function? Okay. But even that, you switch it out and it's like, okay, well now when we drop this is shattering and you're gonna like stab your dog.
Yeah.
So it's stuff like that. That's like, this is not a one-to-one replacement. We gotta work through this first.
Yeah, exactly.
Yeah. So what are some of the hottest new technologies, some of the hottest emerging technologies and innovations in the recycling and sustainability space?
Yeah, I would say, from my point of view, the hottest technologies and newest innovations are these concepts that bring in the idea of circular carbon rather than always focusing on circular plastics. So plastics are carbon-dense materials, and they don't necessarily always have to go right back into the same exact function they were in their first life. And many of us are aiming for that. That's the goal. Like you take a polymer, you deconstruct it back to its constituent parent monomers, and then you repolymerize it back to that polymer. And you can do that an infinite amount of times. And the reality is we didn't make plastics today to really do that. That was never the intention 70 years ago when we made LDPE for the first time. And that's really hard to do with a robust carbon backbone. But the cool part about things like polyethylene is that it is just a carbon backbone. It's actually a chemist's playground for functionality. You can add so much to that backbone to make it something new. And so I think that's kind of, to me, some of the hottest, coolest technologies coming out is this idea of, okay, well, it's much lower energy if we can oxidize PE to dicarboxylic acids. And now those diacids are monomers for nylons and polyesters and polyurethanes. And so now you're putting a single-use waste material into now these, quote, engineering plastics that are usually designed for longer use. And they're not collected in a blue bin at home, so they don't have recycled content coming in. But you're finding these kind of novel carbon pathways to bring these waste carbons back into a new lifetime. I think that's really exciting and really cool. And then, of course, there's this, I'm a little biased because this came out of our group, but I do think that this is incredibly exciting, impactful technologies for the future. And I don't know if you guys saw this science paper that our team released 3 weeks ago.
Did it win awards?
What's that?
Did it win any awards yet?
Not yet, but it's definitely going to.
It's 3 weeks old, Mercedes. Give it 2 more weeks.
But we're proposing a chemical and biological tandem technology. So for such a long time, we kind of siloed everything into their own places. Like mechanical is only mechanical, chemical is only chemical, biology is only biology. So we actually proposed and did a successful case study on this tandem process where we took mixed plastic waste. In this particular case study, it was polystyrene foam cups, it was Dr. Pepper PET bottles, and it was HDPE milk jugs that we ground down together. And while those plastics in and of themselves are not bioavailable to microbes, if we oxidize them in very mild conditions to these smaller oxygenated molecules, they are bioavailable. So we developed a pre-treatment step that's about 2 to 4 hours where we can oxidize these mixed plastics into these small molecule oxygenated intermediates. And then instead of building out energy intensive separations to try to isolate those compounds from each other, we engineered a bacterium that we funnel the soup of molecules into, and the bacteria has a metabolic pathway for all those carbons. And so what it does is it acts as this tiny little chemical factory, and essentially under incubation will digest those carbons and express one single bioproduct. And in this case, it's polyhydroxyalkanoates, or PHAs, which are biodegradable plastic packaging. And so we're trying to show the world that this is a very low energy and a really cool tandem design to take highly contaminated mixed waste. And instead of pyrolyzing it down into this mixture of all these carbon links, this mild oxidation plus the bacterial digestion, we can create PHA polymers from it, which are sold at about $4.50 a kilogram. So they're quite high value. So this was just released. It's kind of a lot of buzz around it right now because it was a science paper. We call it Oxfun, and we're also taking it to the International Space Station this year, which is also really cool.
You know.
No big deal. Just sending it to space.
Just a little NASA action.
Yep. So it's pretty cool. That was my little plug for our work, but it is incredibly novel concept to do this type of combined technology. And as we think about, you guys mentioned previously to me this Greenpeace report that came out and all this fear about the pollution that can come from some of these chemical recycling plants that are very high energy, where they're going to be located. This is another kind of pathway that's a little more environmentally friendly, low energy, and manageable.
So you mentioned that the PHAs can be used for biodegradable plastic packaging. What specific types of packaging applications would you foresee for this?
Sure. Most of the PHAs we see on the market today they're not the best materials ever. Their mechanical properties leave something to be desired for sure, but they're considered
best mechanical property. I mean, it's suited to a specific application. It could be the best polymer ever.
It could,
right?
It could. And I mean, they're quite useful. They just haven't had widespread adoption because, biopolymers are more expensive and all of those things. But typically you'll see PHAs used in the green compost bags. The Starbucks has recently adopted a PHA straw. They can somewhat be they can be injection molded. So they'll be molded into utensils, cutlery, that kind of thing. So kind of similar applications we saw in the early 2000s, the PLA being really pushed into. PHAs are kind of being pushed into that type of application space. The cool things about PHAs is that they don't require industrial composting conditions to break down. They will degrade quite naturally in the environment with half-lives of 90 days. And so that's pretty exciting as you think about how much plastics we unfortunately lose to our natural world, which should never happen, but unfortunately it does. And even if recycling was absolutely perfect, because of the small nature and lightweight format of plastics, rural cities, crowded areas, we're still going to lose plastics to the environment. And so as we build in more biodegradability and have that play into recyclability, I think those are two concepts that we have to consider together.
I want just to send a public service announcement out to anybody who works for Marriott. If you could please get on the PHA straw thing.
Yes.
I went to my cousin's wedding in Key West, and let me tell you, drinking
the anger,
drinking pina coladas, drinking these frozen drinks out of a paper straw in the Florida weather, it's not a good look.
It's a joke.
It's a joke.
Yes,
it's a joke. I mean, we all feel bad for Sad Turtle, but I'm so happy. I'm so happy to hear about these PHAs.
Let's move to PHAs.
Yeah. the paper straw thing. Oh, I totally respect everything people are trying, and they are, in terms of, again, the half-life in the natural environment, it's significantly shorter than plastic straws are, of course. But I remember I saw a picture last year, this image that was really impactful of a plastic Starbucks cap, the curved caps they put on the iced coffees. They're like domed.
Oh, yeah.
That with a paper straw in it on the ground. And so when you think about the problem of that picture, you're just like, oh, that's hard to see. But that's another cool thing about PHAs. I actually do envision a future where they play more into some of these biopolyesters that are on the market, like the PLAs, the PBATs, the PBSs. PHAs will play a role there. And I think there's really great opportunities to start combining these polyesters together to achieve performance properties that you need for certain applications, but have now again, going back to half-lives, one single material where maybe your domed cap is a PBAT and your straw is a PHA. And hopefully that ends up in composting where it should go. But again, if that's lost to the world, will be gone into biomass, carbon dioxide, and water within 4 years.
So if you guys at all get a call to help on this, please put your priority on pina coladas in the Florida area.
I will test out humidity conditions for Florida and specifically pina colada drinks for these PHA straws.
We appreciate you doing the Lord's work.
I actually I was just in Florida yesterday before coming back to Colorado, and I drank a pina colada. So I feel like we had a moment, Mercedes, where we were connected. We did. And we didn't know it. So, and it was delicious. I hadn't had one I can't even remember, and it was delicious.
I love it.
So, I mean, I suppose getting back to like the point of this interview, besides
we can stop talking.
So can you tell us some of your work at Novaloop? And I know it led to some of your involvement with the with NREL and the Bottle Consortium. Well, my talking is going very well today.
Just the mention about
I'm already pina colada
on that. It is Friday, so
it is. I mean, it's dangerously close to pina colada time. So, yes. First off, can you tell us what BOTTLE stands for in Bottle Consortium?
Yes, definitely. So BOTTLE is an acronym for Bio-Optimized Technologies to Keep Thermoplastics Out of Landfills and the Environment. And that came together beautifully to make BOTTLE. We thought it was very clever. However, many people now think we only work on plastic bottles. So that's been kind of annoying because we work across the entire space of plastic waste, not just bottles.
So, can you, you had mentioned in our correspondence that the one thing that you've focused on lately in your work is the deconstruction of plastics. Can you tell us some of the work that you've done involved in the breaking down of plastics, maybe outside of the PHAs?
Yeah, definitely. So we've adopted this terminology of deconstruction in bottle because we want to move away again from the concepts of it has to be depolymerization back to the constituent monomers, or using phraseologies that people are getting bent out of shape about these days. Like if you use advanced recycling, they get mad. If you use chemical recycling, people will get mad. So we felt like deconstruction was the quote bipartisan word to use here, but it's actually quite fitting because if you think about these plastics, they're not only just polymer architectures that you need to deconstruct to harness back the carbons, they're also formulations, right? That none of these plastics exist as a single polymer chain. They are highly formulated, most likely over-engineered, but that's because polymer producers get really proud of their formulations, and that little additive gives them that little leg up in terms of more UV stability than that polymer producer's polyethylene. And so it's, when we think about the chemical recycling pathways or chemocatalytic pathways, it is deconstructing of a formulation, not just a polymer. And so we've actually focused a lot on very low energy pathways to do this. We've seen pyrolysis and gasification really take off in the media in the last couple of years. And those technologies have been around a long time and are quite matured. And they are capable of breaking bonds in mixed plastics. They can handle more contamination than mechanical recycling. There's significant pros there, but they are high energy inputs. They require a lot of energy to break carbon-carbon bonds. So we've been trying to explore other catalytic pathways to break down these recalcitrant materials and do so in a way that makes sense, that we're actually getting useful chemicals and building blocks out of the process, because that's the next challenge. Is it's actually not that hard to break down polymers. It does require a lot of energy, but it's not that hard. It's just
not that hard.
And then after that, you just take it and send it to space, and it's just another
Tuesday. And then you let space deal with it. But the real problem is now becoming the downstream separations and chemical engineering and unit operations that we need to actually take these soups that not only are the deconstructed plastics, but they have dirt in there and heavy metals and all this stuff that comes from our waste streams. How do we actually outfit systems to recover pure and useful monomers from that without just doing tons of distillation columns that are so energy intensive?
Right.
So we have a really big task on our hand, but this has been our major focus within Bottle, is exploring not only chemocatalytic, but biocatalytic pathways to take apart these polymers, and then in tandem with that, building out novel separations technologies that will allow us to recover highly pure streams without having to put in enormous energy inputs. So that's our big goal, and we're making a lot of progress. We're a research institution though, so we're always operating, not always, but we're mostly operating at the benchtop scale with line of sights to scale. It's our goals. But we're new. We've only been around for 2 years. So we're definitely in discovery phases of many of these technologies, but some of them are starting to look incredibly promising as we go into the future.
Yeah.
Yeah, it certainly sounds like it. It's very exciting, the work that you're doing.
I'm almost afraid to ask this question, but I have to assume, what's been the greatest accomplishment of your career so far? Because my guess is, even though you've told us like 65 amazing things, there is also something else out there.
Definitely. I have an answer for this because it is something I'm incredibly proud of. And I also want to give a shout out to this group of people. So you guys know I spent time at Novaloop for a few years before I came to NREL. And the Novaloop technology is an oxidation technology. So I already had this background in oxidation before coming to NREL. But what we were doing there was oxidizing polyolefin waste to these distribution of these dicarboxylic acids. And it's not just one chain length diacid. There's a lot of them in there. And at the time we were trying to figure out, should we start trying to isolate these from each other and use distillations to get maybe adipic acid and succinic acid out? But we had this idea of okay, could we use the mixture of diacids and make new polymers from them and avoid that big separation step? And in the world of polymer science, as you guys probably know, what's pounded into our heads as students is that you will never, ever make a good polymer from a mixture of monomers, that it's like impossible to do based on Carruthers equation. And I was really intent on trying to prove them wrong.
I love it.
And this was a blood, sweat, and tears of not only my life, but many of my colleagues that I worked with there. Shout out to Cody Higginson, who is one of the best polymer chemists I've ever met in my life, as well as Russell Pratt, who worked on this with me too. And I mean, that just a couple of weeks ago, On Running announced using that product that we developed from recycled, broken down polyethylene to make these new polyurethanes. The On Running shoe company is using that TPU in the outer sole of their new Cloud 9 running shoe. And that moment, like seeing that announcement, I mean, even though I'm not there anymore, I was like, oh my God,
we did it.
It's incredible. I mean, when we signed that JDA years ago, I cannot even, I mean, truly my life was 10-hour days at the benchtop, 7 days a week, every day of my life. I mean, I became a better polymer chemist, and those were my patents were those polymers. But there was a lot of moments where I was like, this will never work. And the fact that it's now at the level where it's being adopted into a shoe, it's just awesome. And that's like so cool, because it is going to be one of the first footwear products that has chemically repurposed plastic monomers, and it's pretty awesome.
That's really a big deal. So does everybody get one for Christmas?
Yeah,
they gave us all a pair of shoes when they started working with us, and I still wear them today. I actually love their shoes. But yeah, I don't know, I don't work there anymore, but if they all get a pair of the Cloud 9s, I'm gonna reach out and be like, can I have one? And
here's the thing, I'm gonna need a pair though.
Yeah, I definitely need a pair. But that moment was just really I mean, almost like brought tears to my eyes. It's really cool to see a new product being adopted. And you guys coming from industry know that is so rare. Like it really is. Yeah. We do not get a lot of new polymers onto the market. So that was cool.
Do you have like an affectionate name for this polymer? Like a nickname?
So they brand named it Oystra. That's the actual brand name of it. It's supposed to kind of represent how oysters naturally recycle water. I don't know, but we used to call it Cirque, which I thought was cooler, but apparently someone already had that name, and the trade name industry is crazy. But that's the trade name for it, is Oystra. And at the time, we just called them TPUs. We were pretty boring. Didn't have any cool affectionate names for them. We were just boring old polymer scientists.
Very cool. So I know we're running out of time here, but we hear you're working on a book. Is that right?
We need to know about it.
So one of the scientists I already mentioned, Cody Higginson, who's still with Novaloop, him and I are writing a book on chemical deconstruction technologies for plastics. So trying to create a comprehensive view of what's out there beyond just pyrolysis, and which is what so many people think of when they hear chemical recycling. So we're writing a book. We're doing this with the De Gruyter publishers, and we already have a really beautiful cover that an incredible graphic designer made for us. I am blanking on his name right now, which is making me feel so bad. So I'm going to probably email you guys.
We'll put it in the show notes.
And put it in the show notes. But it's a really fun picture of polystyrene kind of unzipping, and then he made the snow in the background that's like foamed polystyrene. It's just really fun.
I love it.
So that's in the works. It's been something that we've been working on for a while and would love to be done with this year. That's the goal. But yeah, stay tuned. Hopefully that will be useful for the world and be a guide to people who start going more into this space and trying to understand what the word recycling means, because as you guys know, there's about 100 different definitions for that right now.
Yeah. Well, I certainly hope that we'll definitely be getting a copy of the book when
Yes.
you do release it. And I hope that sincerely that you hit your mom up for that picture so you can use that for your about the author.
Put that in the about the author page.
Bring it to any book signings.
I will say so when we got the International Space Station project, NREL came in and took new pictures, and I was really adamant. I was like, I am going to pose the way I want to pose for this picture.
Nothing weird.
Yeah, like I'm in charge now. And so I love the picture they got of me. And it's finally like, oh my God, there's a picture of me in a lab where I don't look like a total dork. And I'm just like really excited about that. So maybe I'll do a side-by-side comparison of like, this is when I was young and this is me as a boss.
You should do one of those like where I was, like how's it or how it's going kind of.
Yes.
How it started, how it's
like
going.
Big bangs in the one of me in grad school. And I went through a phase, so
you know we all have
going through that right now. So
yeah, oh, they look great. I mean, you curly hair though, so it looks so cute,
right?
And yeah, I love it.
Well, Dr. Kat Knauer, thank you so much for joining us. Thank you for all of the blood, sweat, and tears you do put into sustainability and circularity, making our industry and our world a better place. And we can't wait to see what you do next.
Yeah, thank you both for having me. This is so much fun, and hope that some of your listeners also enjoyed it and learned something from it. So thanks a lot. I appreciate it.
Thanks.
Thanks.